Okay, today we're doing multiplication strategies for equations with fractions before solving. SAB page 379 to 380. I'm going to do a couple problems here first before you get going to your SAB page. So I want to talk about when you have something like 2/3 times 15, that can be written multiple ways. So one of the ways that it can be written is like 1/3 times 15. So you're finding what 1/3 of it is, which is 15 divided by 3, which is 5, and then multiplying that by 2. So basically what happened was we took the whole number, divided it by the denominator, and then multiplied that product by the numerator. Okay, another way to look at it is when you take 2/3 times 15, is that could be like 2 times 15 over 3, which is 30 over 3, which is 10. So still the same answer, just a different way of writing out the problem and thinking about it. Okay, the last way is that you can just take that number and you can do 2 times 15 over 3. Okay, so all I did was put it together over that numerator. Then you can cross out because 3 divides into 15. 3 goes into 3 one time, 3 goes into 15 5 times. Now I get 2 times 5 over 1. 2 times 5 over 1 is 10 over 1, which is 10 whole. Okay, let's try a couple more. So we've got 3/10 times 12/5. So that can be rewritten like 15 over 120. So I did 3 times 5 to get the 15, 10 times 12 to get the 120, and then simplify down. Okay, so this is just simplifying, right? Dividing it out, down, divide by 5, divide by 3. Okay, another way to look at that is 3 times 5 over 10 times 12, which is what we did there. Okay, let's give those a try, give a few a try here on this next page. Okay, any strategy that you want to use, just show your work on your board. So what I'm going to do here is I'm going to show you a couple of the different strategies. We'll work through them. So this first one, I'm going to do 30 divided by 3, which is 10. And then I'm going to take that and I'm going to multiply that by 2, which is 20. Okay? So I took the whole number, divided it by the denominator, found that answer, multiplied that by the numerator to get 2/3. Okay, let's try it a different way. We're going to go 2 times 35 over 5. Okay, which is the same thing as simplifying then down, and I can get rid of this 5 and this 35. The 5 becomes a 1, the 35 becomes a 7. So now I have 2 times 7 over 1, which is 14 over 1, which is just 14. Okay, so just a different way to look at that. Okay, any way that you guys want to look at these is fine with me, whatever you're most comfortable with, whichever strategy you guys like the best. Okay, let's try another one. 6 times 4. Okay, it's not going to be easy to take 4 and divide it by 6, right? So what I'm going to do again is I'm going to go 5 times 4 over 6. Okay, 5 times 4 over 6. I could, oops, 5 times 4 over, that's a 6. Sorry, that didn't look very 6-ish. I can simplify the 4 and the 6. Cross out 2 goes into both of them. 2 goes into here 3 times, in here 2 times. So then I get 5 times 2 over 3, or I get 10 over 3. Okay, and then I'm just going to leave it like that. Or I could make it an improper fraction. Okay, either or. Right, you can think about how many 3's can you pull out of there. Well, I can pull out 3 and I have 1/3 left over. Okay, whichever way you guys want to look at those. All right, let's go on and try a couple more. I'm going to skip down here. If you guys feel like you need some more practice, you can do some of these others, but I'm going to skip all the way down here to number 2 and work this one out. Okay, so we're going to look at this like it is 2/16 times 4. Well, I can simplify 2/16. I know right away that 1/8 is the same as an equivalent fraction, so I'm going to do that, and then I'm going to multiply that by 4 over 21. Okay, then what I get is I'm going to put this, so it's like I can move these around. I can say 4 over 8, right? 4 over 8 is 1/2. Okay, and then I can multiply that by the 1 over 21 because it doesn't matter if I move them around. Okay, when I do that, then I can see that I'm going to get 1 over 42. So did you guys see what I did? I put the 4 over the 8, and then I went on from there. Let's try another one down here. I'm just going to do 10 times 10, which is 100. And I'm going to do 9 times 7, which is 63. And I'm going to be done with that problem. Okay. Continuing on. Okay, I'm going to take, it's like you've got this whole equation. So you can think about it like this. You've got 7 times 10 over 15 times 21. Okay, and it's all together. So I can simplify this portion of it, this 10 over 15. 10 over 15 would simplify down to 1/3. So I can do 1/3. Okay, and then 7 over 21, because 7 is over 21 here, would simplify down to 2/3. Okay, so then I've got 1/3 times 2/3, which is 2/9. Okay. All right. I'm going to go ahead and go forward. If you need to rewatch some of these or watch how they're done, please do so. If you need some more practice, try out some of these other equations up here to make sure you're understanding it. On this next one, the equation that doesn't mean the same thing. Find the non-equivalent equation and circle it, please. All right, let's try some real-world story problems with this kind of thing in it. In the Fireside Ski Shop, 11 out of 28 of the ski caps have tassels. Of the caps with tassels, 7/11ths are blue. What fraction of the caps are blue with tassels? So we're going to multiply, okay? So showing my work, I'm going to have 11 over 28 times 7 over 11, okay? When I work through this, right, I should notice right away I can actually get rid of these. They become a 1, and I get 7 over 28. Oops, not 21, 28. Sorry, guys. Okay, and then what I should know is that both of these can be divided by 7. 7 divided by 7 is 1. 28 divided by 7 is 4. So 1/4 of the caps have blue tassels. Blue and with tassels. Let's try another one here. Okay. In the shop, 27 of 32 of the jackets have zippers. Of the jackets with zippers, 8/9 have hoods. What fraction of them have hoods? Okay, so 27 over 32. We're going to multiply that by, I'm going to extend it out, 8 over 9. Okay. Hopefully you're seeing that 32 and 8 have something in common. I can divide each one by 8. If I divide 8 by 8, I get 1. If I divide 32 by 8, I get 4. Okay, 27 and 9 have 9 in common. When I divide 9 by 9, I get 1. Okay, when I divide 27 by 9, I get 3. So then I'm just going to multiply across. 1 times 3 is 3. 4 times 1 is 4. So 3/4 of the jackets in the shop have hoods with zippers. Okay, try one more. 5 of the 16 workers in the shop know how to ski. 1/5 of those who can ski know how to snowboard. What fraction of the workers can ski and snowboard? Okay, so 5 out of 16. That's my first fraction because 5 out of 16 can know how to ski. Of that, which of means multiplication, 1/5, right, know how to snowboard. Okay, so what I should see right away is when I get my fraction written like this, these two cancel each other out because they each become a 1, right? 5 goes into 5 one time, 5 goes into 5 one time, now I have 1/16. So what fraction of the workers can ski and snowboard? 1/16 of them. That means only one person can. Okay. I want you guys to respond to Puzzled Penguin. I'll read it to you if you need it. If not, you can kind of fast forward onto the next page. Okay. Dear math students, I have a string that is 3/4 of a yard long. I need to take 7/12 of it. Can you see how I solved the problem at the right? Now I'm wondering about my answer. When you take a fraction of a fraction, should you get a smaller fraction? But my answer is larger. What mistake did I make and how do I correct it? So I want you guys to respond to Puzzled Penguin. Help him correct it. And this is where we'll start tomorrow with your groups.